Chamomile! Hello dudes, dudettes, duders, and everyone in between. Today we're getting into video RAW as an acquisition format. For the first part, we'll cover what makes RAW unique, and when we get granular, we're going to focus on the Blackmagic Pocket Cinema camera series. While there are dozens of cameras that shoot RAW, the Pocket Cinema series will likely be most people's introduction to the format. It's reasonable to think that we can help support the widest cross-section of filmmakers by focusing on that camera series. Of course, if you have questions about other cameras, please leave them in the comments below and we will address them in a future video. By the end of this video, you will understand what makes RAW unique as an acquisition format, what its limitations are, how it functions in relation to single native ISO cameras and dual native ISO cameras, and the unique quirks of the Blackmagic Pocket Cinema series. While you will be better at thinking about video production, you won't be better at producing videos. To become a better filmmaker, you need to make films, and I encourage you to either do that at the end of the video or right now. RAW as an acquisition format opens up tremendous control in post-production, but to understand the scope of what RAW unlocks, you have to understand a couple of core concepts to filmmaking, primarily ISO and color balance. ISO is a term that goes back to the good old days of film. It refers to a film stock's sensitivity to light. The higher the ISO, the more sensitive it is, but this comes at the cost of more grain. The lower the ISO number, the less sensitive the film stock is, but also the less grainy a properly exposed image will be. A lot of this terminology carries over to digital cameras, and one of the fun things about shooting digital is that you can change the ISO from shot to shot. Sort of. Well, not really. Actually, not at all. Sort of. It's weird. When you change film ISO, you're actually changing actual stock, which is actually made up of actually differently balanced chemicals. When you change ISO on your camera, you're not changing the sensor plate. What you're changing is the amount of gain being added to the signal sent from the sensor plate. If you remember from the last video, the sensor plate is a fairly passive device. It observes photons and reports that to the camera. It judges not. You can amplify the signal coming from the sensor plate the same way you can amplify an electric guitar, by boosting the gain. And like sonic amplification, the louder you go, the more noise you drag along with you. The chain from the sensor plate to the storage media goes like this. Sensor plate, analog gain, analog to digital converter, digital gain, recording. As you amplify the digital gain, you drag the noise up along with it, kicking and screaming. This will result in a brighter image, but also one with more noise. This relationship between noise and the increase of brightness is so similar that whether you're working in film or digital photography, it makes sense to retain the same nomenclature. It's only when you get under the hood that the differences become meaningful. Let's get under the hood. To understand the difference, you have to understand native ISO. Native ISO is the setting at which your camera operates most efficiently. When you go above it, you're increasing the gain of a fixed signal to compensate for low lighting. When you go below the native ISO, you're attenuating a fixed signal to appear darker. Either way, you're starting with a fixed signal. And if the signal is fixed, it's best to use it without gain or attenuation, right? Well, yeah, it's best, but it gets really expensive really quickly. If you lock into native ISO, that means you make your image brighter or darker by changing the amount of light in the environment you're shooting, which gets very costly very quickly. For this small environment, I'm using $2,000 of lights, and that's a small spend on a small space. But it's the difference between low budget and high budget cinematography. If you want to look cheap, adjust the camera to the lighting you've been given. If you want to look expensive, adjust the lighting to make the most of the camera you've chosen. What's cool about this concept of native ISO is that RAW video records the information from the sensor plate without any gain or attenuation. The sensor plate reports the photon count to the camera, and the RAW codec jots it down. This means that you can offload ISO adjustments from the software in the camera to your post environment. The other luxury afforded by RAW is the ability to adjust your color temperature in post. This is nothing short of a game changer if you've been shooting compressed your whole career. Look, I don't want to be the bearer of bad news, but the monitor built into your camera, it isn't color accurate. It's simply meant to be a reference for shooting, not the final word on color or gamma science. If you're using your on-camera screen as a reference for color and exposure and shooting to a non-RAW codec like ProRes or H.264, you're baking that incorrect information into your video files. With RAW, you can get close on monitor and still have full flexibility in color adjustment when you get to post-production. As you adjust white balance on your camera when shooting RAW, you're not affecting the actual footage, just the metadata of the footage you're shooting. Of course, you should at least be using a gray card when shooting, and we will get into that in detail in another video. Let's talk metadata. Whenever you're shooting, there's going to be metadata, and the kinds of metadata you can find in a file depend on the type of file it is. For example, a JPEG has different metadata allowances than Red Code RAW. There's a lot of information that can be in RAW metadata, including lens, make and model, iris, color space, light information, gamma, white point, tint, camera firmware, and LUT, just to name a few. The more information about the video that you can offload into the metadata means the less information that's getting baked into every frame of your actual video footage, and it gives you more control in the post environment. And this is the beauty of RAW. While that doesn't cover everything, it's enough of the bird's eye view to get you started. Moving forward, we'll turn our focus to the wonderful world of affordable RAW, brought to you by Blackmagic Design. To understand what's special about the Blackmagic RAW, we have to understand the majestic glory of dual ISO. Remember native ISO? Some cameras have two of them. It's one of those ideas that's brilliant in its simplicity. Instead of having one amplifier in your camera, use two, each one operating at a different amount of gain. This means that you don't need to push the gain or attenuation as far, and the new chain looks like this. The big difference you'll notice is that there are two analog gain devices, one outputting ISO 400 and one outputting ISO 3200. From there, the Blackmagic amplifies or attenuates the signal digitally, and this creates two bands of signal that are unique to this line of cameras. To understand these bands, we're going to look at them theoretically, and then we're going to see how that applies in camera. What you're seeing is the exposure chart for the Blackmagic Pocket Cinema 4K. If this is your first time seeing a chart like this, it might seem a bit technical and daunting, but it's actually pretty easy to read. Along the x-axis, you'll see ISO. The y-axis represents stops, with 0 being middle gray. You know, these gray cards, they have a defined value of 18% gray or middle gray. Again, I promise that we'll get into them in another video. You'll see that when you set the camera to ISO 400, middle gray is falling exactly on the line for 0. This is no accident. 400 is the native ISO, and ISO 400 will be the most neutral tuning for the sensor plate. As you go left along the chart from 400, you'll see that middle gray is climbing, and this means that you'll need to add more light for your middle gray test card to land middle gray on your footage. As you go to the right of ISO 400, you'll see your middle gray go down on the chart, meaning that you'll need less light to make it land middle gray on your footage. You'll also notice that as your ISO gets lower, you'll have less data to work with in the highlights before your signal clips, but more to work with in the shadows. As you go to higher ISOs, you'll see that more data space is being allocated to highlights, sacrificing information in the shadows. You'll also notice that there's a clipping point in your highlights and lowlights, and this stays consistent across the whole chart, but only at ISO 400. Let's look at what happens at ISO 3200. As you travel right on this chart, you'll see that the clipping points are mobile depending on your settings. The reason I bring this up is because clipping is very important when you're combining analog gain with digital gain, and very easy to understand when you're working with raw footage. It's one of those things that has practical applications that are super easy to demonstrate. I'm all in on that stuff. Because you're digitizing the signal at ISO 400 and then adjusting gain from there, what's clipped at 400 will be clipped at 1000 and 100. There's a ceiling and a floor to the raw data, and ISO is an interpretation of that data. To see this in action, we'll look at some footage shot on the Blackmagic Pocket 6K, and we will clip the high end. The first thing we have to do to make this experiment work is to barely clip the signal. To do that, we'll turn on false color and stop the iris down until there's no clipping at all. Then we'll open it back up 2 stops to reintroduce a clipped signal. What you'll see is that as we adjust the ISO, the only thing being affected are the parts of the image that aren't clipping. and that confirms exactly what the chart is showing. As we adjust ISO, we're moving middle gray, and as we do, we sacrifice detail in the highlights to get more detail in the lowlights. But the values for absolute white and absolute black don't move. As tends to be the case with digital workflow, once a signal is clipped, it's clipped. With that in mind, when we're shooting on Blackmagics, we use the iris and shutter speed to eliminate clipping in the highlights. Clipped highlights are the most obvious giveaway of digital video, and if we're going to crush the signal, we'd rather do it in the shadows than in the highlights. The eye is naturally drawn towards brightness and can tolerate more loss of signal in the shadows than it can in the highlights. Don't believe me? Just compare the online conversations surrounding highlight abuser J.J. Abrams to those surrounding shadow abuser David Fincher. Between those two, who has taken more hits for their visual flair? Back to the camera. Things are about to get a bit strange. When you're shooting on a single native ISO camera or on film, the higher your ISO, the more grain you're going to have. This doesn't hold true for dual native ISO cameras. The ISO 400 amplifier covers ISO 100 to 1000. The ISO 3200 amp covers 1250 to 25600. This means that when you switch from ISO 1000 to 1250, you're going from a signal at maximum amplification to a signal at maximum attenuation. We know that when you amplify a signal, you also amplify the noise, and the same holds true for attenuation. When you switch between ISO 1000 and 1250, you will notice a significant drop in noise. In addition to this drop in noise, there's another more nuanced change going on when you switch from ISO 1000 to 1250 on a Blackmagic Pocket Cinema camera, and to understand it, we have to go back to the charts. When you're shooting at ISO 1000, you have maximum information allocated to the highlights and minimum allocated to the shadows. When you go to 1250, you're inverting that, with more information being allocated to the shadows and less being allocated to the highlights. What this means for practical application is that if you're shooting something with a lot of nuanced highlight information, like clouds with the sun behind them, you'll want to lean towards ISO 1000, not ISO 100, where you might naturally go if you were shooting film. If you're shooting something where the majority of the information is in the shadows, you'll want to be at ISO 100 or 1250. Or you might want to hew close to ISO 400 or 3200 because that's where you have the cleanest balance of image, noise, highlight signal, and shadow signal. Of course, shooting RAW offloads those decisions to the post process. Instead of picking from the full menu of ISOs on the camera, you can choose between the 400 range and the 3200 range, knowing that any adjustments you make in post will be identical to the changes you make in camera. When you're shooting in a studio environment, it makes sense to take the time to balance all of these disparate factors and create the image exactly as you want it. When you're shooting run and gun, it's good to understand these concerns and how they're going to affect your image, and what leeway you have in making your decisions in post instead of on location. The delightful thing about shooting RAW is that you have those options. Before sending you out into the wild, I'd like to discuss compression and sensor windows on Blackmagic cameras. We shoot full sensor when we shoot on Blackmagic cameras, and that's because there are no options for scaling when shooting RAW. I've heard people online explaining this as a hardware concern, that the Pocket cameras aren't powerful enough to do real-time scaling of RAW data. I think this is more a philosophical concern. RAW is a one-to-one recording of what the sensor is seeing. When you scale, you average nearby pixels together to get a new value that none of them actually recorded. Philosophically, that could be argued to not be raw data. In fact, I'm arguing it now, and I agree with myself. Because there's no image scaling, when you change resolutions on your Pocket camera, you're cropping the sensor. While 6K takes up the entire frame, 4K only uses half of the available pixels. This is true across the board, as you're seeing on the screen. For that reason, even if we're finishing 4K, we'll still shoot full sensor if we're shooting RAW. This opens up worlds of reframing possibilities in post-production that wouldn't be available if we shot crop sensor. Look, shooting uncompressed 6K RAW for a video that will end up on Instagram might seem a little silly, and honestly, it is. And that's why we never do that. We shoot compressed 6K RAW and adjust our compression to what the client can afford. The more they want to spend on image quality, the less compression we use. The more conservative they are, the more compressed we go. Frankly, by the time it lands on Instagram and is being viewed on a phone, it's undergone compression way more heinous than anything we could ever do in camera, even if we were shooting ProRes proxy. That is the fortune afforded with a pocket cinema camera. But to access the higher functionality, you have to understand the higher functionality. I hope I've given you the tools you need to shoot technically better media. The unfortunate thing is that you've watched this video to the end and I've offered no help in making you a more creative filmmaker. This video is a celebration of numbers, not of art. To celebrate art, you have to close this window, grab a camera, and find ways to apply the ideas you've been studying. Since the rest of this video is going to be channel updates, now is the perfect time to close out and make movies instead of watching them. First note, this is our first video produced and delivered in 6K. We did it that way so that you could see the difference between compression ratios on the raw footage. Of course, YouTube's algorithms probably undermined my best efforts. Hey, you remember when YouTube was a Flash site? Wild, hey. As always, we have a Patreon and there's a link to that in the description. I've been appearing as a panelist on Office Hours and there's a link to that in the description. I always forget to mention this, but I've uploaded a collection of light leaks that you can download from my website for free if that's what you're into. Finally, please, for the love of God, stop watching YouTube and go make your art. And when you're done, hit me with a link in the comments so I can stop making art and watch your YouTube. Bye.